Hi everybody, this is Tor Storley and I am back with another video. Today in this video I will continue my look at the functions and new features in DuckDB 1.1 version. So what I have done is I prepared this notebook here, and as you can see I have put some notes in here, and I wanted to show you this because all the way back to when I did my first DuckDB video with DuckDB and Harlequin, I was always irritated with the CLI because I couldn't figure how do I clean it out so I don't have to look at all the crud as I go. So let me show you. Here is my window here. And by the way, if you're going to open your database in the CLI, you can use a statement like this. Open and then the pointer to wherever you store your DuckDB database. And you could put the extension DuckDB, or you can say DB. That's fine. Either one will work. So this is how I open it, and I already opened it. So what I wanted to show you is if I just run anything in my CLI, and I'm just going to say from something like that. You see I get a bunch of stuff on the screen here, right? The query is not important. But notice, how do I clean this out? And I tried like clean or CLS, that didn't work. So I tried all these kind of things. And then when I looked up here, I saw there's a drop thing there. So when you drop it down, you can see you have all these different menu items. But there's one down here that says Command Palette. You see that? And if you go to Command Palette here, I saw this clear buffer. And what you can do is you can go here and you can simply clear the buffer. So if I ran my query again like this, I can either use that short key, which on mine is a Shift C, and there it's gone from the screen. So it's a quick way of getting rid of the stuff. You can also set up your own here. So you see this clear buffer? You can edit it, but you can set up a hotkey and then you can just press that and it will disappear from the screen. So that's a quick way of doing it. All right, enough about the clear buffer. Now what I want to do then is I want to today look at lists, structs, and maps. Those are very familiar to you if you work in Python, for example. You work with lists, you work with structs. My relationship with structs was pretty much formed when I started my data engineering job at AbbVie. And I worked on Palantir Foundry platform for the global sales force. And what we had to do was write PySpark code. And we had to deal a lot with structs because structs kind of laid out all our files. And sometimes we listed all the jobs we had to do and all the files we had to import in structs. So for me, that rings a bell. You might be familiar with structs when you see JSON files. That's structs typically mixed with lists and so forth. There's also mappings, where you kind of mapping one value to another in a key value pair. So we'll look at some very simple examples here because I don't want to overdo this. Some of this you'll use more than others. I suspect you will use lists the most, and then structs perhaps, and much less mapping. So accordingly, I set it up that way. So if you look here, I got some queries. So let's just copy these queries for the list, and let's open our CLI like this. I'm going to do one at a time here. So I'm going to say this, Control C, and I'm going to paste it here. So as you see here, I'm creating a regular query here where I'm putting in some values, and I call it T, and then the column will be called value. So when I select value from the virtual table or the made-up table T, then I'm going to see what I can get. So when I run that, this is a regular query. So I'm getting back Tor, Jerry, Sandy, Barb, and Jenny, because those were the values. So that's a plain vanilla query. There's nothing to do with anything, lists or anything here. The second query I want to run then is this one. And again, very similar, but the only difference now is that notice I put these brackets around it. And by doing this, you're making a list object. So when you query a list, the output will be in a list format too, as you can see here. So when I run this, you can see now it's inside a list object. So that's how you create a list very quickly. You simply put the brackets around it. Now you can also run list operators over your lists. And again, the topic here on this video series is new features and functions in DuckDB version 1.1, meaning functions for older versions as well, but the newer feature I will point out. Here is one of the new features right here. Notice you can create a variable and you give it a name and you set it equal to, and here I'm using kind of a literal, which is just a list. Now the variable can be literals or singular values, what have you, or multiple values within an object like I'm doing here. But it can also be a sub-select. So you could have a select query here that will be stored in that variable name. And it will hold it in memory till you get rid of it. So until you remove the variable from your session. So as you can see here, I'm going to create a variable. And in order to get value out of the variable, in order to query it, you have to use this function called getVariable, parenthesis, and then you have to list the variable. And this is important because I struggled with this in the beginning because I forgot you have to put it in as a string. So even though you have it as a variable here, in other databases you usually refer to it like this, but here they want it as a string. So that's why you have to put the quotes around it, as you see here. I got a single quote here. Let's create the variable. So we'll go this, Alt-Tab, and I can paste it here. And right now I got a variable. When I go back here now, I can simply copy this, select get variable vnames, add, and I give it a name, and I call it names. And when I paste that now and run it, you can see, sure enough, I get the same output as over here, because this is in effect this, right? The variable is in effect this. All right, very good. So that's an operator you can query out from the list. Now you can also slice it. So for example, here I am slicing the list and I'm looking for values, one value only in position 3. And here it starts at index 1. So Torby 1, Jerry be 2, Sandy be 3. So let's see if that's indeed the case. So let me go Alt-Tab this, paste it. And as you can see, sure enough, Sandy is number 3, index 1, 2, 3. So that's how that works. You can also, as you can see here, you can do a range. And by doing a range, you're basically slicing it like this. And here I'm saying pick up 3 through 4. So Sandy is 3, Barb is 4. So that's how you get that output. Next one is another slice, but here I'm including a step. So what does that mean, a step? Well, when you run this now, I'm looking for 2 through 5. So if you think about it, this is number 2, 3, 4, 5. So I'm looking for everything from here, but I want to go in step of 2. So I want to find the first, and I want to go in 2 steps. I would skip Sandy and hit Barb. So let's see if that works. Sure enough, you can see I'm getting Jerry and I'm getting Barb because it has a step of 2. All right, so that's a slicer. You can also return a list, and you can basically pop from the back of the list. It's called array or list. And when you do, you can see here when I run this, and again, remember I have this buffer up here, this Shift-C. So when I press Shift-C on my Windows machine, you can see it just clears the buffer. So that's really nice. Here, when I run this, as you can see, I'm removing the last value from the list. So if you recall, the list was Tor, Jerry, Sandy, Barb, and here in this case, I popped it from the back, so Jenny disappeared. So that's how you can remove it from the back. You can do the same thing from the front. So when I do a front here, so now you can see I got the Jerry, Sandy, Barb, and Jenny. So here I say I removed Tor from the list because I removed it from the front. Okay, so that's another operator you can use. And again, there are many of these. You need to go into the documentation for DuckDB and search for lists, and you'll find all these kind of, they list the values like this pretty much, and then something like this. But here I'm just making full queries out of it so you can see how you can actually use it. There's nothing revolutionary here, but so here I'm going to create a second variable called vnames2. put some other names in here. And then what I'm going to do, I'm going to use this flatten function. And notice I'm grabbing my vnames1, which is the one we created up here, this one. And I'm creating this new list, v2 here. So what I want to do is I want to combine these and flatten it. So that's what this one is going to do, combining the lists on one flattened record. Here you can see I'm combining this new list 2 with the name list 1. So now there's 8 of them, right? And if I notice this at 5 because I haven't loaded the second one here. So if I go back now and I run that length one more time, notice now I'm getting 8 because I combined the two using that flatten function. So now there's 8 elements in this list. So that's why I say 8. Very good. So now we got that one. And what we can do now is we can also aggregate, okay? And this one is kind of nice because you have aggregation functions. If you look under functions in DuckDB and you look at aggregate functions, you're going to find a whole list of the usual suspects like min, max, sum, mode, median, all kinds of statistical stuff, etc. So if you look here, you can do the same thing in these lists, okay? You can do the same thing in these lists. Notice what I'm doing here. I'm creating a variable called vNumbers, and I'm doing 2, 3, 25, 17, 10, 19. So I'm creating numerics here because I want to run these aggregate functions over it. So if there was names, you don't really want to run min and max and stuff over names. It doesn't make sense. It will simply do it based on alphabetic order. But if you look here now, if I run this guy in here, let me clear the buffer, Shift-C, and paste it in, aggregate function. Notice what it gives you. It gives you the min, the max, mode, median, and mean. So as you can see here, this is the list that we're talking about. And therefore, we ran these list aggregate over that list. And here, I'm simply specifying the type of aggregation I want to do. Min, max, mode, median, mean, etc. And there's many more of these. You just need to go and look on the list aggregates in the documentation. All right, so let's clear the buffer one more time here, and let's go back. So that's how you can run statistics over lists. So instead of doing the taking out and put them in a regular table format, you can do it directly over the lists. You can also sort lists like this. So if you look, you have a list sort method. And again, I'm just referring to my numbers lists. Notice now you got 2, 3, 10, 17. So it's sorted the list in ascending order. You can also unnest, as we've probably been discussing many times before. And unnest the list means we basically take the value out of each of these list items and put them into one column. So I'm calling this unnested lists. So as you can see now, you simply take each element and you put it into a table format. So that's what the unnest does. It puts each element into its own row. Okay. Now, there's also ways of looking for whether or not where is the first number that is not a null. Okay, so if you look at my query here, you can use this list any value. Any value will look for the first non-null value it finds. In other databases like Oracle, you use something called coalesce. In SQL Server, I believe you use coalesce. And I don't know about Teradata and those other types of databases, but you use the coalesce and it will basically go through each one and check if it's a null, and it will pick the first one it finds that is not a null. So notice here in I get null, null, and then a number, right? And then some nulls, and then some numbers, and then some nulls. So here I'm looking for any value. Here I'm looking for the list position. And notice the first one was any value. So in other words, no, it's not this, it's not this. Yes, this is the first one, and it found it here. Oh, 8. I looked for number 8. I'm sorry. I looked for number 8. So 8 is here, so that makes sense. All right, so that was in that position. Value exists. Is 6 in this list? Yes, it's here. So that's true. It found it. And the last one is it doesn't exist. Well, 63 is not any of these items in this list. So that should be a false. So that makes sense. So that's some other functions you can use for against lists to detect certain things. All right, another thing you can do, you can filter things and you can make them distinct, etc. So let's see how this one works out. Let me clear my screen again so it's clean. And let's paste it in. And here we go. So here I'm looking for distinct values in the list. And notice what I did. I repeated some of these values. Here's a 12 twice, right? And so it's looking for any distinct value. It's also looking for unique values, okay? And here it's looking for list filter. So let's find out what the differences are. But we'll talk about this list filter in 1 second. Let's cover on the other two first. So notice when you use the list distinct, okay, it will return the actual values, 10, 2, 3, and 12. Because 12 was repeated twice, right? So therefore, it only uses it once because it's distinct. Notice the nulls gets ignored. So that's why you have 4 here. And notice the unique values is a count. It's a count of unique values. So you can see that's 4 values in that list is unique. So that's how you use the list unique. This filter is a little different because it uses something called a lambda expression. So I'm setting up a filter over the same list as above. Then I'm creating a variable n for number that will go to n greater than 2. So in other words, look for any value in the list where the list element is greater than 2 and the list element is less than 12. And they call it filtered values. So if you look, well, n is 2. Well, this one is 2. This is greater than 2. 3 is greater than 2. 2 is 2. 12 is greater than 2. But we're looking for n less than 12. So that doesn't qualify. So the only one to qualify is the 10. So therefore the answer is 3 and 10. So that's how this list filter works. You set up a lambda expression like this. All right, so now what we can do, we can also set up another list comprehension. So if you look at this particular one here, I got a list comprehension. So what is a list comprehension? Well, you basically set up a list comprehension as some code logic within the list. Notice I start with the brackets here, the list brackets, and I end with the brackets here. So based on whatever list, which is this, that I call list names, I'm saying create a variable called name. So for name, the variable that's going to hold each value in this list object, which is this. So I'm saying for name, name, in this list, if it starts with J, so in other words, if that variable name here that I created starts with J, then I want to include it. So when I run it now, I'm getting Jerry and Jenny because both of those starts with a J. So if you're not too familiar with list comprehensions, make sure you look at that. There's nothing different here from what you can find in Python, but this is done in DuckDB. So it's super flexible, as you can see, and they incorporated many of the features you find in SQLite in the database, and they incorporated many of the features you find in Python, as well as being able to talk to other programs like Julia and R, etc. So it's very flexible. Okay, so that's a list comprehension. Now we're getting to aggregate statistics. Now what do I care about that? Well, you can run regular statistics over regular tables, but you can also run statistics directly over lists. So if you look here now, I'm going to clear it out, Shift-C on my computer. If you look at this query here, okay, this needs a little explanation, I guess. So let me do this. Okay, I have a table in here that is called managers. So as you can see, this table has a bunch of timestamps, and it has a symbol because this is based on financial data, stock data. This is a fictional data set you can find in R's performance analytic package, and we'll get back to that in future videos. But basically what it boils down to is you have these symbols, and then you have the rate of returns. And one of these symbols is something called ham tree. Okay, so that's kind of what we're making a list out of, as you can see over here. What I want to do then is copy this query and paste it in here. And what I'm doing is I'm running statistic average, median, standard deviation for the sample, the skewness, and kurtosis. And we'll get back to some of the meaning of this in later videos. Also notice what I'm doing. I'm placing this for the return, which is this list up here. But I'm doing this fast cast, as I call it, which it basically is a cast statement that will say something like cast return as decimal 10,5 decimals, basically. So you cast it on the fly here, basically. So you get 5 decimals for each one here. So that's what this colon decimal does, okay? And again, this looks very similar to me, like stuff you find in C++, where you have these double colons, etc. And again, DuckDB is written in C++, so that makes sense. People are thinking in C++, you know, coding language way of thinking. So anyways, let's run this and see what we're getting. And here you can see you ran statistics over this list up here. You found the mean, median, standard deviation, the skewness, and kurtosis. All right, so you can actually run statistics over this as well. And I'm not going to dwell on the statistics. We'll probably talk some more about it in a later video. And next thing then is structs. So now we're looking at structs. So what does that mean? What is a struct? Well, you recognize structs from these squiggly ones. And if you've seen JSON, you've seen structs before. So what I'm trying to do here is I'm creating a variable. Again, remember, this is a version 1.1 new feature. You can create a variable and use it in your code. So here I'm creating a variable. And let me paste that in. And when you look at it, you can see it is a list of a struct. You see the squiggly mark? Now, what is a struct? It has this squiggly mark. It has a key, and here key is called name, colon, and then a value, Tor. Here is a key called age, and a value, 26. A key called salary, 25,000. A key called bonus, value, 0.15. So I'm creating 3 of these struct items inside a list, and that's what that variable vstruct does, okay? So now what I can do, I can say, hey, let's unnest it. And remember from the previous examples we did, the unnest basically will take the list objects and it will parse it out and it will create a row, a unique row for each one of those values. And that's what the unnest does. But in our case, we don't have single values. Remember, we have structs. So each one of these struct is treated as one object. That's why you're getting one struct object per row. So you can see it here. Okay, so that's our struct unnested. So again, you use the same principle as you did on list. Use the unnest function. Then what I want to do, I want to retrieve a specific value from those structs that I just showed. So when I do a thing like square brackets 2 here, I am going to look through these rows and I'm going to pick the second row here because that's what I'm saying. And as you can see, sure enough, it finds Beth, which is the second row here. All right, so that will take care of Beth. Now, if I want to go deeper into Beth's row and I want to find out her salary, how can I do that? Well, you simply drill in again. You say, hey, go to Beth, row 2, and grab the salary column. And what happens here is this is actually the key value in the struct. It's a key value. So I'm looking for the value that is connected to this salary key value, meaning the key. So when I run that, you can see it's 45,000. And if you go back to the screen here, you see Beth key value is salary is 45,000. So that's how you can extract out from the struct one single element. Okay, now we also can receive the sum of everything. So even though it's a list, and now it gets a little more involved because it's kind of harder to understand. But if you look at the thing, this is our stuff, right? And what we want to do is we want to kind of combine this plus this plus this. The 15% is not going to be based on the salary. The 15% is going to be based on a $10,000 they want to split for each of these employees as a bonus. But it's going to be 0.2 of the 10,000, 0.15 of the 10,000, and so forth. So when I run this now, there you go. So notice the total salary was 135,000. The total bonuses was 5,750. Therefore, the salary plus bonuses is 140,750. So you can still do all kinds of aggregation, like I see here, over list object. So that's pretty cool too. Okay, finally then, I have a very, very short thing about maps because I don't think I ever use maps, and particularly not in a database. But the mapping will basically be when you have a key here, you're going to map to a value. So as you can see in these examples here, let me just run and create a variable, and I'm going to call it a struct variable like you had before. And this is nothing new here. We'll try that out. So that's the vStruct object. Then we can run a regular query just to see what it looks like. And notice the way I do it. I unnested the struct, and then because I called the struct the person, then I can dig into the name, age, salary, and bonus like this. So when you do that, you can see, Shift-C, you can see here that you're getting basically a table that looks exactly what a table would look like based on that list, or that struct object. So now, finally then, I'm simply going to do a basic mapping here. And why do I do the mapping? Just to show you that you can map it back again into structs, basically. So if you look here, I'm using a map entries function and the map keyword for each row. And I'm going to map each one to name, age, salary, and bonus. That's going to be the keys. And the values are going to come from down here, from the person object. And remember, this struct here contains name, age, salary, and bonus, and so forth. And that's how I refer to those. So I made them all into varchar. So you can still map them, but when you retrieve them out again, or you parse them out, you probably have to convert them back into numbers again. So for this query to work, I have to fast cast it into varchars. So when you look at this query now, and I go back to my CLI and paste it, this is what it will look like. So again, I took it from here, looking like this, and I made it into here. And notice, key is name, value is Tor. So the reason that is like that, let me see if I can actually make that work. I'm going to copy this query one more time, paste it below, and I remove this map entry. And if I do, so the only thing that's different now, I took out this map entries. So let's see what that will do. So I'm going to paste that here and paste it and run it. Notice, so if you use that map entries, you're getting like, hey, the key is name, the value is Tor, the key is age. So you're using the key value in front of it. If you just use map here, you're just getting the key and the value, the key, the value, etc. But notice, you don't get it in a correct form. You don't get it with the colons, you get it with the equal sign. So it's slightly different output depending on your situation. You can play around with this and see what you can make it look into. I hope you liked this video. It ran a little longer than I was hoping it would run, but hopefully you got something out of it, some food for thought. And again, if you like my videos, please support the channel by giving me a like and consider subscribing to my channel if you haven't done so. That will really help. And the algorithms will pick up my videos much easier so more people can actually see my videos. So if I'm going to put the work effort in, I really appreciate if you support me. Thank you so much. I hope you have a fantastic day or a fantastic night wherever you happen to be in the world. We'll see you really soon. Bye-bye.